How many loonies is 1 million worth? How many toonies? How many $100 bills? What is another name for 1 million?
So one loonie, as we know, is $1. So that means a million loonies will be $1 million. And then toonies are the double of loonies. That means 500,000 toonies will be two times 500,000 will be a million. So then that will be 500,000 toonies. And then the last question: what is another name for 1 million? We know that 100,000, 100,000 equals a million. So we just wrote that in.
Okay, so over here, for the first one, when we have 1 million loonies, the loonies represents what place value? 1 loonie. Ones, right? Okay.
Yeah.
So you'll need 1 million loonies to have $1 million. Now I want to look at the next one, and Joseph said something that he used a math terminology. He said that a toonie, he compared a toonie to a loonie. What did he say? Does anyone remember what word he used? Because we need to learn how to use these words. Yeah. The toonie is double. So if a toonie is double a loonie, you need a million loonies. How many toonies do you need to make $1 million? Sorry? How many toonies do you need to make $1 million? So if you look at 1 million loonies and 500,000 toonies, what can we say about the amount of toonies that we need?
We need the amount of toonies of half.
Half, right. So when you double the value of the coin, you need half of them to reach your desired $1 million that we would all love to have, right? No? Okay, fine. How many $100 bills would you need? And you said you would need 1,000, right?
10 100,000.
Okay. And the last question here, what is another name for $1 million? That was a little trick. And they said 10 100,000s. Is there another way to say 1 million in a different way? So 10 100,000s is correct. Yeah.
110,000.
100. Well, see, it's so humid today. It depends on there. 100. Which one? 10,000s. So I'm gonna 10,000s. Is there another one? If he's got 110,000s, you should notice a pattern here. We have 10 100,000s, 100 10,000s, 1,000 1,000. Should notice a pattern here right now. What's next?
Maybe it's
10,000 hundreds, and the last one,
100,000 tens.
100,000 tens. A town has a population of 24,897 people. A new family moves in. What might be the population of the town now? Model this using two methods. What mistake can be made if someone doesn't understand the order of place value?
For the two methods, first I made a place value chart and added the numbers to it. Then 24,897 plus 4 equals 24,901.
So your family has 4 people.
Yeah.
Okay.
For here, 9 plus 2 equals 11, so 1 goes up there, and that becomes a 10. So 10, you can't do that, so you put 0 and put a 1 up the 8. So 8 plus 1 equals 9. Then it's going to be, there's nothing under the 4 or 2, so it's just going to be 4 and 2. So I get the same answer, 24,901.
Okay, so here, I think you meant this for this to be 7. So 7 plus 4, which still gives you the same answer, but that's okay. So here, if you had the place value blocks, his group showed that you cannot have a double-digit number in a place value. So He is moving over and trading in to get a bigger place value block. Now, what about this last question? What mistake can be made if someone doesn't understand the order of place value? So if someone adds 4 to this number, what mistake might they make if they don't fully understand place value?
I think 24,947.
They might make a mistake with the tens. I think they're going to make a mistake with the ones. So if they add a family of 4, what might their answer look like if they made a mistake in place value? Isha.
24,900.
They could do 900. I'm thinking that if they don't carry over the numbers, that their answer might look like 24,891. Or it could look like this. And I have seen this before. Just in case you think I am not being honest with you, I can show you. They might do something like this, which gives them an answer of 248,911. What mistake would you have to make to record that answer right here? So we have 7 plus 4 here. Keep that in mind. Yes, Aiza. They didn't carry over the numbers, right? Is that what you meant to say? Yes, she is nodding her head, by the way. So I'm not telling her the answer. But yeah, sometimes they forget to carry over the ones, and they don't. So basically, this is like their ones column, and it's got 2 digits. You do not want that.
So 7 plus 4 is 11.
Yes, it is.
They might forget to regroup.
Regroup. That's the word. I even forgot it right now as we were filming this. But yeah, regroup. They forget to regroup. And that is a common mistake. I am a number between 7 million and 8 million. All my digits are odd. All the digits in my thousands period, which is right here, are the same. All the digits in my units period, which is this right here, are the same. The sum of my digits is 31. What number am I?
So we knew that the first number in the millions was going to be 7 because it's between 7 million and 8 million.
Right, between.
Right, so if it was 8, we couldn't do any more than that because so we knew it was going to be 7. And then we did 7, 7, 7, which equals 21. And then we did 1, 1, 1 because they're all odd, which equals 3. And then we added it up here. So 21 plus 7 plus 3, which equals 31. And then here we just did it in reverse. So we did 7 million, 100 and...
So this reverse method, right away, that should be an automatic answer because you're adding. Doesn't matter if you add 7 plus 7 plus 7. So let's make it 21 plus 3 or 3 plus 21. It gives you the same answer. You cannot get a different answer. If you were subtracting 24 minus 3 and 3 minus 24, you get 2 different answers. So for adding, it doesn't matter what order. So that's what made this easy. And then your next...
Yeah, and then we did the same thing here. We did 5, 5, 5, which they're all odd, and they're the same. And then we did 3, 3, 3, and they're odd too. And then we added it up here, and it equals 31. And then we did the same thing we did here. We did it in reverse. So we had 4 answers.
Perfect.
To the end.
Okay. And remember, odd numbers are 1, 3, 5, 7, 9.